welcome to the first track of the first workshop of beginner track. The link to the slides is at the bottom of this slide right here for people who are watching a recording. And our Discord forum on the ACM Discord is beginner track right there. So you can contact us anytime you need. All right, getting back into what is competitive programming? So competitive programming is the race to solve the greatest number of algorithm challenges as quickly as possible. Specifically, it's not a hackathon. In a hackathon, you have maybe 2 days, you end up with a piece of software. In competitive programming, that's not the case. You might have like 2 hours, 3 hours, 5 hours, and you'll have a series of these problems where the answer will be some sort of algorithm or something clever, some clever trick that you need to come up with. And your program needs to run quickly, and you need to try and code it up quickly. And it's all like this big, exciting race. So there's an emphasis on problem solving rather than software engineering, which is just important to state. This is not a hackathon. It could be cooler. Okay. So why would you want to do competitive programming? For one, it's fun, I guess, depending on your definition of fun, but we like being here and we hope you will like it too. It's also useful. So like the algorithm and data structures questions that you'll be dealing with here are also similar to the questions often like asked in like software engineering interviews. And I just want to give a quick shout out to interview track. If that specifically like software engineering interviews is what you're interested in, we have another track, interview track, that runs Thursdays 6 to 8, and there'll be a bit more on that later, but just know we'd love to have you here. But also you might want to check them out because they'll be specifically helpful with that. Also, it's social. Like look at all the people who are around you on Zoom right now. I know I've made a lot of friends. Oh yeah, I've made a lot of friends in ICPC, and hopefully you could too. And also you can win prizes. That is cool. It's always fun to win prizes. Lots of t-shirts if you're looking to win clothes. And also we have a weekly contest that has a $25 Amazon gift card prize draw. So the more problems that you answer, the more entries that you will get. And yeah, so that is some nice incentive to competitive program. Alrighty, and so what will your competitive programming journey look like at ICPC? Well, ICPC, we ran a track in the fall. It's called Beginner Track. You could have gone to that track. If you're here, you also don't have to have been to that track. So we're like an independent continuation of Beginner Track called Beginner Track Plus Plus. That's why we're all in pink right here. And so we welcome people of all like skill levels. That is our challenge, and we hope to service all of you. Alrighty. And then we also have in spring quarter, we're going to have Code Sprint LA, which is our the contest that we make. And it could hopefully be like your first foray into a real competitive programming contest, which is exciting. It's a lot of fun. We make the problems ourselves. It's like an official thing, and it's cool. So stay tuned for more information on that. And then from there, or really from here, with the knowledge that you will learn here, you can go into our ICPC team, which is world class. They're going to the world finals, I believe, this year, or was it last year? Because of COVID, things are kind of shifted around. But the point is, we're sending people to the world finals, and it's really exciting. And you can train with that team on Sundays, which I'll go into a little bit more information on that in a second. We also have advanced track, which basically has the same goal as us, which is to teach you algorithms and data structures, but they want to teach stuff that comes up in like more difficult and competitive programming problems. And so stuff like that would be like string matching or like segment trees. And if that, what I just said, means anything to you, then maybe check out advanced track. Things that are not associated with us would be like Google Code Jam and other contests like that, which offer like prizes and opportunities. And that's really exciting. Do it with friends, it's fun. And lastly, maybe you don't want to do any of that stuff. Maybe you're like, I've had enough competitive programming after you finish this, which fair enough. But you will leave this workshop being a better programmer and a better problem solver, no matter what you plan to do afterwards. Alrighty, so who are we? We are Beginner Track Plus Plus, and our goal is to give you the knowledge and confidence to solve a whole bunch of competitive programming problems. You don't need any prior experience, but if you have it, you're also welcome here. We'll also be catering to you. And the topics that we'll be covering this quarter would be ad hoc problems or problems that don't fit into another algorithmic designation. That's what we're doing today. We're also going to be covering graph theory for 2 weeks, going in depth with that, dynamic programming, and we're going to be doing something new we haven't done before, bit masking, which is exciting. We're going to, every week, we're going to be having the workshop, except potentially week 5, but stay tuned for more information on that. But every week, Wednesday, 6 to 8 Pacific Standard Time, this Zoom link right here. And I'm just going to introduce myself really quickly. I can't believe I didn't do that yet, actually. I'm Raya. I am a 4th year math and computation major, and this will be my 4th quarter working on beginner track with ICPC. I guess we'll go in order of who's on the slide. So Anna, if you could introduce yourself, that would be fantastic.
Hi everyone, my name is Anna. I'm a 4th year CS major. Previous quarters I've taught interview track. I just wanted to test and see myself how great beginner track is, because I got a lot of reviews. So looking forward to working with you guys.
Hello, my name is Carson. I'm a 2nd year CS major, and this is actually my 1st year doing ICPC related activities, but that should not deter you from wanting to join and be a part of it. You can apply to be an intern no matter how much experience you have, and I'm excited for this quarter.
Hi, I'm Ilya. I'm 1st year computer science and engineering major. And yeah, this is also my 1st year in ICPC. Yay.
Hi, I'm Suhas. I'm also a 1st year computer science major, and I'm just very excited to be here on beginner track.
Yay, thank you so much. Alrighty. We are one event that's happening this quarter, Beginner Track Plus Plus. Other events that are happening this quarter, in case you're curious about the ones that I mentioned earlier, I saw Daniel had a comment, question about that. We have interview track, which is happening Thursdays, 6 to 8. So the first meeting is happening tomorrow. And they teach the stuff that you need to know for interviews, including technical stuff. And they also work on like these softer skills you might need for interviews. So that's exciting. They meet on Zoom. You can check out our link tree for more information on that. Advanced track, unfortunately, meets the same time that we meet. I mean, it's all recorded, so you won't miss out on anything if you want to check out both of them. And we'll miss you here. But also, if you want to check out advanced track, feel free to do that. And we have some other events coming up this quarter that are exciting, like the Cyber ICPC Puzzle Hunt, which doesn't require any CS knowledge, it's purely problem solving, and it tentatively is in person. And finally, we have the ICPC training team. You can train with the team. Everyone's welcome. It's fun. It's on Sunday afternoons, and you can DM Rishi for details. He is another officer at ICPC, and his Facebook link is right on these slides. Alrighty, and I know that was everything I just said was kind of a lot of information. If you want to stay up to date on all of this and more stuff, then you can sign up for our newsletter. It's a new thing that we are doing. So the link is on the slides. You can also just type in tiny URL, whatever, and it should bring you straight to it. Alrighty. Sorry about that. Okay, so you just met us, all of us, about you. All that we ask of you, I suppose, is that you have like basic programming experience. That is, maybe you've taken CS31, or you generally know about like arrays, loops, strings, variables, stuff like that, and that you're interested in competitive programming. And we will do the rest. Alrighty. So thank you for sitting through all the informative stuff. Now, let's get started. So we'll be using for our workshop Caddis, which is the cutest contest platform. And that means that we'll be hosting our contests on there. You'll be getting your problems from there and submitting your solutions to there. And we'll go through all of that right now. So the first thing that we're going to need you to do is to create a Caddis account. You could do this through these links. You could also just Google like Caddis. It should come up and be pretty self-explanatory. And once you do this, or if you already have a Caddis account, could you please tell us your username? Even if we've done this in past quarters, I don't believe we have it, or I don't know where it is. So if you could tell us your username in this Google form, that would be fantastic. And it's currently 6:17. So I'm just gonna give you 5 minutes to do that. So until 6:22 to sign up and tell us who you are. Thank you. If you have any questions, please unmute or put them in the chat. Oh yes, thanks. Yeah, there's a Google form that you could drop your username into. Thank you for asking. Thank you for answering. Okay, hooray. Hopefully there was enough time to create your Cadis account and tell us your username. If not, feel free to keep doing it while I just continue setting up, because I guess we have limited time. So the next thing is your tools, like your competitive programming toolkit. What sort of stuff are you going to need? Well, the first thing they really want to stress is perhaps the most important thing almost is pencil and paper. Because before you're able to tell the computer how to solve the problem, which like, right, is what coding is, you need to know how to solve the problem. And so like drawing out your solution, like we're very visual thinkers, most people. And so it's not uncommon to be like, wow, like what? I didn't see this. And like to understand what little trick the problem needs you to do after you're drawing it out. So definitely try out the possibilities with pencil and paper. And I feel a need to mention this especially because I feel like we have this idea of like, you know, it's competitive programming. So you're like typing furiously at your computer, like that's not what it is. You need to give yourself the time. So I feel like when I was a beginner, at least I was like, if I'm not programming, I'm doing it wrong. No, if you're using pencil and paper, or if you're coming up with a solution, that is what competitive programming is. So hooray. But other than that, or also if you need to use like a pen or like, you know, a whiteboard or something, it's fine. Just like, you know, the idea of working it out is what's important. All right. Also, we recommend that the language you use be C++. Why? Because it is very fast. Also, it's the language of instruction for the majority of UCLA CS courses. So chances that you know it already are high. And also it has a robust standard library. So a lot of the things that you're going to need or want to solve these problems, C++ will have built in for you, which is fantastic. But of course, if you feel more comfortable in another language and you want to use that, like Java or Python are also popular competitive programming languages. The problems that we provide will be solvable in those languages as well. So don't be too worried. Alrighty, an editor and compiler setup. The chances are that you have one already. But I know a popular one would be like, you know, VS Code, Xcode for Mac. I wouldn't necessarily recommend that. I personally use like Emacs in the terminal and like compile it with G++. Whatever you could do to compile with G++. If you already have a setup, then this probably doesn't matter. But if you don't and you want help coming up with a more permanent setup like this, then talk to us after the workshop and we can help you out. Otherwise, if you don't have one yet, for now, we recommend you use Replit. It's great. It's going to have all the stuff that you need, and it's just online, as fast and easy. And to get there, all you'd have to do is follow this link right here or type this into your browser, and it can bring you to this one for C++, for Python, or for Java. And it's great, and it'll allow you to code along with us here for now. Yay. Alrighty. So we finally went over all the fundamentals you need to know to get into a problem. Now, how do you actually approach a problem? When you see it, what are you going to want to do? Already. So all these problems can look very different. Some of them could be like really difficult. They have like this really long, like flavor text or whatever. But in general, there's going to be 4 main steps that you're going to need to follow to solve the problem, of course. And that's 4 main places that you can get like tripped up. And so the first being read, like reading through and understanding the problem statement. It's obvious, I guess, but this part has tripped me up more times than I would like to admit. I solved the problem, realized that I solved a completely different problem, and wasted a bunch of time. So making sure that you read through and understand the problem statement is important. And then you need to devise a solution to the problem, of course, which is perhaps the difficult part. You know, it's the part that requires creativity, and you need to know what algorithm or data structure or whatever you need to use to actually solve this problem. But don't worry, because this is up to the part that we're going to stress in this workshop. And hopefully you will leave feeling like a problem-solving master. Then you need to code your solution, which would be use the solution that you devised to create a program that takes the correct input and produces the correct output. Again, I feel it important to note that these could be considered two separate steps. So sometimes, you may know what the solution is, but you might not know exactly how to code that. You might not know the necessary data structure or whatever to get that done quickly and effectively. So we'll be going over that too. And also debugging. In all likelihood, you're going to need to debug your solution and figure out why your code isn't providing the correct output. And we have some tips for that too, and we'll be working through that as well. Alrighty. So to show you all of this in action, let's work through a problem. The example problems for today, you can access them at this link. So you can type this into your browser or just click it if you're on the slides. And you can click join contest. It will be in like the right-hand side, kind of below this bar right there. And you're gonna wanna open problem A, which is Peragrams. I'm gonna give you like a minute to do this. Tell me if you're having trouble, by the way, because sometimes it can be difficult to find that join contest button or work with the interface if you haven't done it before. Welcome, by the way, to the people who just got here. We're just getting into the example problem we're going to do today on Caddis. You can check the tiny URL link Carson just so kindly dropped into the chat, and it's also on the screen on the slides. And the link to the slides is right there at the bottom of these slides. All right, fantastic. Hopefully you've had a chance to do that. And I don't see any questions, but if you're having trouble with that, I know people get tripped up there. Okay, so what do problems look like? What's your problem gonna look like? You will have, sorry about that. Distracted by the chat, my fault. The problem statement. So the first part, which is just the flavor text, and it's basically telling you what the problem is about. Suhas said earlier, like Caddis problems are fun because they have a whole story behind them and try to make it seem like useful. And this, you're gonna see all of that in the problem statement. Then it's gonna have the input output description or IO description, which is gonna tell you what a program is gonna give you and what it expects your code to give it back, right? And so it will give you all that in excruciating detail, hopefully, but you can actually see that in action with these sample test cases, which will be below that. You can see, which is great for running your code on, because then you can actually practice and make sure your code's doing the right thing before you have to submit it, which is fantastic and very helpful. And then you're gonna have this little section in the top right. You see the details and submit button. All you really need to know for now is that that's where you're gonna click submit and you'll submit your solution. Okay, so the problem that we're working on today is Peragrams. I'm going to give you like 2 minutes to read it, and we're going to work through this together. And so until 6:32, we will read through that. Sorry, I'm in a different time zone. We're only slightly different, so it's not weird. Okay. Also, as always, if you're having difficulty, please ask questions in the chat or unmute yourself and ask a question. But we'll be going over this in 1 minute. Alrighty, fantastic. Hopefully you've had a chance to read over that. And we're just going to make it really explicit in the next slide. So an anagram is a word that's formed by rearranging the letters of another word. So for example, you can rearrange cinema into Iceman. That's a cool one. And then a palindrome is a word that you read it the same forwards as you do backwards. So for example, madame, or like reading it backwards, it's still madame, or nurses run, and it's still nurses run. These are cool ones, by the way. These are just off Google. It's crazy what's out there. Anyway, a paragram is a combination of the two of them. So it's an anagram of a palindrome. That is, it's a word that reads the same forwards or backwards, and you just scrambled up all the letters, right? And so an example of a paragram would be AAB, because you can scramble up the letters. And one of the ways you could do that is you get ABA, and that is a palindrome. So it's an anagram of a palindrome, it's a paragram. Alrighty, and AAB is not a paragram because you read it forwards, it's ab, you read it backwards, it's ba. And the only way you can scramble it around is to get ba, and that is still not a palindrome. So that is what a paragram is. Do we have any questions about this? Cool. Fantastic. I'll take that as a no. If you do, at any point, feel free to ask. All right, so now that we understand what we're actually solving, like what we actually have to do, the best place really to usually start with the problem is with the example test cases. So we have two here. We kind of just went over sample input 2. And so we're going to do sample input 1 and sample output 2 and see if we can see why the answer to 1 is 2. So let's go through the first test case together. Okay, so our goal, as stated in the problem statement, is to find the minimum number of characters we must remove to get a paragram, right? So let's say we just removed B. So then we're left with AC, which itself is not a palindrome. And the only way to like shimmy that around is to leave it at CA, and that is also not a palindrome, right? Because AC backwards is CA, and those are not the same thing, right? Okay, and by similar logic, if you remove just A or C, it will not create a paragram. And so we can't remove only one character, right? But if we remove, say, both A and B, then we're left with this string C, and this is a palindrome because you read C backwards, forwards, and then you read it backwards, and it's still C. Crazy how that works. So because a string is an anagram of itself, C is a paragram. So we know, and we can see why we need to remove at least 2 characters. Alrighty, and so now that we've exhausted basically all of these test cases, the 2 that we have, what is our next mode of action? We're like, okay, how do I solve this, right? Another good way to approach a problem is by creating your own test cases. So for this one here, I started with a palindrome because we already know by definition that if it's an anagram of a palindrome, then we're going to need to remove 0 letters. So not a lot of extra work there. We just take this palindrome, move the letters around, and so we say our input is this and our output is 0. Why is this the case? And it's perhaps easier to see here because I color coded it, and this is, I guess, another push for using pen and paper or visualizing things that can really help you see things. But each letter is paired up with another letter. So it looks like we can just count the letters. If there's an even amount of letters, then it's an anagram of a palindrome. It's a paragram. And this makes sense, right? Because if it's a palindrome, then we're going to read some letters forwards, and then we're going to need to read those ones again on the back end. And so this is the pattern that we're observing, and it also makes sense to us when we think through the problem logically. But can anyone think of some case that we're forgetting here? that is,
You
please go ahead.
you can have one letter that only has one, which would be the vertex, I guess, the center letter.
Yay, perfect. Thank you so much. Exactly. In sample test case 2, we see this too, that if we have a word with an odd number of letters, there was obviously going to be at least one letter that occurs an odd number of times. But there are, of course, palindromes with an odd length. So we can see that each letter has a pair except for one of them, because we can have one be, as you said, the vertex. So fantastic. So that sounds good. We have even, we have odd. Now do you think we've covered every case? We have, as far as we know, all words with even letters and all words with odd letters, odd number of letters. Okay.
What's
Yes.
the condition on empty string?
Pardon,
What's the
Claire?
condition on an empty string?
Oh, good question. That's a fantastic question to ask. I think if we check the like problem statement, it should say, I believe, that they won't give us an empty string. But that's really important to check. And maybe we should check that. If I can, if someone,
I put it in chat.
okay, cool. Oh, thank you so much. Yes, but that's a fantastic question, especially for an interview, to ask like what the bounds are and stuff like that. And that should always be specified in the input output section. But yes, okay, so empty string is covered because it won't happen. And we have all words with even letters and all with odd number letters. I think we've covered everything. And I'm only asking this because we should always be asking this after we come up with a solution that seems viable, to see if there are any edge cases. But you guys have answered fantastically. Thank you. In this case, we have covered every case. And so our solution is palindromes are symmetrical, right? So every character except maybe the middle one will be repeated. And so all we have to do is count, right? So we count the number of occurrences of each letter. We ignore all letters with an even number of occurrences. We don't need to remove any of them. They're perfectly matched. And then the odd ones, we need to remove at least, we can leave one at most. And then every other one, we just need to remove one to make it even. Perfect. Alrighty. So does this make sense to everybody? If it doesn't make sense to you, please ask a question about it. All right. Okay, cool. Hopefully that means that there aren't any questions, but if you do have any going forward, please feel free to ask them. Okay, and so now that we've solved this problem, we have to code it up. The next step, and coding your solution, an important thing to mention about competitive programming that often trips people up when they haven't done it before is that every solution needs to be a complete program. It needs to read from the standard input and display output to the standard output, right? So just a function like you see on the right here, where it just takes integers and then returns, Caddis isn't looking for that. The cat doesn't know what that means. You need to have like a whole program in C++. You see include statements, namespace, and you're most importantly taking an input and putting out output. That's important. Alrighty. Also, just a tip for competitive programming that makes it perhaps easier is if you don't want to have like a million include statements at the top, you might need to include like algorithm and math or string or whatever. You can just include bits stdc++.h. It has like all of those things bundled into one, really quick and easy to use. You can see here this picture of Tourist. Pardon me, I'm sorry, using that. Tourist, if you don't know him, he's a competitive programming legend. All right. But just a quick note that this isn't a good software development practice. So, you know, because you're basically saying include all of these things, and that is like bloating your program using a bunch of stuff you don't need. That's not good. for software. But for competitive programming, that's great. And there are a few things that you will learn that are great for competitive programming, or great for writing code faster, for making your code go faster, that aren't necessarily great for software development, where you need to, write code that's readable to other people, or that you're not going to discard after one use. But don't worry, because the problem solving techniques that you'll be learning here are the things that will be most beneficial to your software development practice. All right, but just keep that in mind, that competitive programming isn't software development. All right, and for Mac users also, I don't believe this works with Xcode. So we'd recommend using VS Code and compiling it with G++, or just generally making sure you're using the G++ compiler, because that's what it works with. Alrighty. Otherwise, if you just use all include statements, that is also fine and probably good practice. Cool. And the last thing you need to know about coding is how to submit your code when you're done. As we went over, in the top right corner, there'll be this bright green submit button. And so you just click that, and then it'll bring you to this page over here where you need to choose your language, hopefully C++, or really whatever you feel comfortable in. And then you can either choose your file, drag or drop your file, go to the editor, copy and paste your code, whatever you want. Just get your code in there, and then you can click submit, and it will bring you to the page, and we'll talk about that after in debugging. But I want you first to see what this looks like. So hopefully, if you understood the solution that we came up with back here, you might be able to program this up. Also, if you don't want to, and you just want to copy and paste it, I've included a solution code that should work. So you can copy and paste this. And I just want to give you a chance to submit something now that we've worked through this. All right. And normally also when you're coding, you're going to want to test it on your machine. So you could test the sample input and sample output. I know I said this before, but I just want to include it here because it's a great way to get yourself tripped up if you submit it and it doesn't even work on the sample input or output, But just to note that there are sample or secret test cases that your program is going to need to pass. So if it passes the sample input and sample output, doesn't necessarily mean it's going to pass everything, but it's a great test. All right, so I'm going to give you 5 minutes, I guess, to either code it up on your own if you're that fast, or use this sample solution code, which you can copy and paste straight from these slides. You should be able to. And for people who want to code it themselves, I have this solution up on the screen so you remember what we did. Okay, yay. I see that most of you have had a chance to submit, which is fantastic. Thank you so much for doing that. And also, yes, what Carson said in the chat, which was that these are, this is just an example problem. And this one isn't even a particularly fair one because I kind of walked through the solution, just told you to code it up. And in all future problems, that will not be the case. So don't worry about I don't know, submitting it fast or all that stuff. This is not, we'll be having more problems in the future that are more representative of what competitive programming is actually like. But for now, I'm going to move on to, hold on a minute, debugging. So what does a verdict look like? Right, making sure I'm muted sometimes. I do that. Okay. So this is what an accepted verdict will look like. The goal is, of course, to see this, but in a lot of cases we don't, and we see a solution that'll be wrong answer, which is unfortunate, which is to say that your submitted solution doesn't pass one of the test cases. And there are a lot of reasons this could happen, and we'll walk through in a second some things to check for, but mostly it'll either be that your whole algorithm wasn't necessarily correct, or that you missed some edge cases. Yeah, and then time limit exceeded, that's also an important one. I won't walk through all of these because they're not really relevant yet, but time limit exceeded generally means that the submitted solution, the solution you submitted was too slow. That is, you didn't find out a trick, or there's probably a trick you could find out that will make it run faster. And this is a beginner-friendly workshop. So if you haven't heard of like time complexity and like event notation, stuff like that, that's totally cool. But if you have, then an important thing to know is that the bounds of the problem, so like, I guess in this problem, it says you'll have like 26 characters, or I'm actually not sure what it says for this problem, but it's a very important, the bounds are very small. So you can have an algorithm that's basically brute force, or that's like going through lots of solutions. Especially for most of the problems that we're going through here, you can have a solution that's like brute force. And what is a brute force solution? It is enumerating through all of the possibilities. So for example, if you said like, what is the best like path from point A to point B, then you just check all the paths from point A to point B, and that would be brute force. And so if the bounds are small enough, you can just do that. You don't need a clever algorithm. You can just rely on the computer to do what it does, and you're good. But in other cases, as the bounds get higher and they're giving you more data, you're going to need to go through it faster to be accepted. And that's something we're going to go into more later, but I just wanted to plant the seed of why these are like algorithmic problems, even though today we're not working necessarily with problems that have a huge algorithmic component. Alrighty. And also, like more trivial note, your solution has to follow the output specifications exactly. So you need like no extra spaces between words, correct capitalizations, no extra like sneaky little, what are those, new lines? Sometimes those get people tripped up. If your solution or their solution has more new lines, then if they have different amounts of new lines, no empty extra new lines in the middle, and also like correct rounding of decimal stuff like that. And so come back to these pages. If you're debugging right now, hopefully they can be useful, or also come back in the future when you want to figure out like why your program isn't being accepted and you can't figure out why. All right. And with that, so that was our breakdown of what it's like to solve a problem. There's a lot of the things you have to think about. That's a lot. And so I wanted to include all that as a place that you can go back to, right? So that you like have access to these slides. And if you're ever tripped up on any one of these parts, then you can come back to those slides, and it can help work you through what you're doing. And with that, we'll go into our first, and because it's kind of late, only practice problem, which is lost lineup. And this is going to be one that you actually are solving yourself and cutting for yourself. So that will be really fun. So in the contest that you're in, hopefully you can find the page. Actually, because Caddis is kind of weird with this in that if you go to one problem in the contest, it doesn't necessarily have a link to get you back to the contest. But please go back to the slide with it, and then go to problem B and read lost lineup. And I'll give you like, I guess 4 minutes to do that. And then I'll read through I'll just go through the sample input really quick. All right, yay. Hopefully you've had a chance to, you've gotten onto and had a chance to read this problem. If you haven't, please send a message in the chat or unmute and ask for help. But for now, get the time, I'm going to move on to walking through what this means. Because at least for me, this was a kind of confusing problem statement. Maybe it makes sense to you, but I'm just going to put it right here. So when it says, like the second line contains n-1 space separated integers, where the I integer is the number of people between the I plus 1th person and Jimmy. I was like, what? What is that supposed to mean? And so here's just a breakdown of the second sample test case, where it breaks down the input. So the input, right, is going to be 1, 2, 0. This is what we have. And so I, then, this is one index, would be 1, 2, and 3. So this is the first person, second person, third person. And so what this is saying is the I plus 1th person has DI people between them and Jimmy. So here, person 2, right, because 1, I plus 1, 2, person 2 has 1 person between them and Jimmy. Person 3, 2 plus 1, 3, has 2 people between them and Jimmy, and person 4 has 0 people between them and Jimmy. Hopefully, you can see how that makes sense. If you have questions, though, please ask them. Right, and to continue or like show why this works, you can see in this sample output, person 2 does have 1 person between them and Jimmy. Person 3 does have 2 people between them and Jimmy, and person 4 does have 0 people between them and Jimmy. And I guess for me, what this question really illuminated was how important it is to go through test cases, because I realized when I was solving this problem that I was solving it incorrectly, and I was confused because I didn't know exactly what it was asking me properly. So reading it can be important. Alrighty. So, and I guess if you want a hint, if there are K people between Jimmy and some person, then what can you say that that person's position in line is? So this will be, I guess, what I leave you with for another maybe 4 minutes to try and like come up with a solution to this. And then after this, we will get into our actual contest where you will have unlimited time and resources to solve these problems. And you can ask us any questions and stuff like that. But for these example problems, since we have solutions and we have a limited amount of time, then you get a limited amount of time to solve them. And I'm sorry for that. But yeah, hopefully I'll give you till like, what is it, 7:11 to solve this problem. Hopefully you've had a chance to look through that problem, get some of the way to solving it. Because now we're going to walk you through the solution. All right, so basically, if there are K people between Jimmy and someone, that means that this person is at position K plus 2, because there are K people ahead of them, right? Plus Jimmy. So we can see that play out in the sample test case where person 2 has 1 person between them and Jimmy, and so they are the second person in line, 1 person plus Jimmy, right? And so all we need to do is read that in, and then just put the person at that point in, say, an array, and we have our solution. Alrighty, so all we have to do is put in the, as I said, I plus 1th person in position K plus 2, which can be tricky because of indexing in C++, which like is why having 5 minutes to maybe solve this isn't necessarily fair. So I'm sorry about that, but hopefully you were able to get some way to the actual solution, even if you weren't able to code it up and submit it in this amount of time. And if you want to get try submitting that, this code is right here. Right. And also, if you have like your code and you want to like compare it to this one, especially because this is the first workshop, so we want to be super friendly to you guys and include as much code and as much information as possible, and that is right here. We have another example problem, which we'll be going over in here at the same time. Oh my gosh, sorry about this. But this is where we're going to end our workshop for today, like the workshop portion or the lecture portion, and get into the contest portion, which is where you get a chance to work with these sorts of problems on your own. Well, not on your own, because we're here and we're here to answer any questions that you might have about them. And also, every problem you solve puts you into the, gives you another like ticket, I guess you could say, into our like prize draw. And so that's exciting. So the more problems you solve, the greater chance you have to win next week. So yeah, we'd love for you to get into that. It should be starting shortly. But first, could you please give us some, we'd love if you could give us some feedback on our feedback form as to how today went for you, how we can improve future workshops. Like, you know, next week, we really do look at this and take it into account. So that would be fantastic. Oh, and lastly, at the same time that the contest is going on, if you don't feel ready to actually like do these problems on your own, we're going to be having like a much more extensive sit and walk through session here where you can just, we're going to have our second example problem, boss battle. It's a fun problem. We're going to be walking through it. So yeah, if you don't want to start the contest yet, you're not at any disadvantage because the contest lasts a whole week from now until next Wednesday. And so, yeah, just stay in this room, but we'll have breakout rooms for each of the problems and you can choose where you want to go.